agenda for today, we have basically continuation of the last session that we had, and I'll take questions on the feedback that I've provided after the last session. We will dig into some of the detail on the mid-surfacing tools, how to defeature a piece of geometry that doesn't seem possible to defeature due to some issues with the CAD, how to defeature a rounded edge that otherwise doesn't want to be defeatured, and then lastly a bit on hex meshing. All right, so what I'd like to start off with, if there are any questions regarding the feedback that I gave on the last session. So if I start to share my screen just momentarily again, we had a number of questions that came in during the last event as well as afterwards through the survey, and I attempted to answer all of them. So I want to give you a moment. If you have any questions on that, or if you did not receive this feedback email, please let me know so I can forward this to you. Or if there are any follow-up questions on this. I'm not going to go through this complete list if there aren't any questions. Otherwise, I'll assume everything was quite self-explanatory. I think the most important thing that I'd like to highlight here is the ability to report bugs and make suggestions directly to the Apex development team. And you do this directly through the Apex user interface. Under the help menu option, there is this feedback option, and that's very useful to use. And then you know your query or your suggestion is actually captured on the system, and you'll actually receive feedback if you provide your email address as well.
Sorry, Paul.
Yes. Hello, Scott.
Okay. I haven't received that. Can you just perhaps forward that to me, please? Those questions, sure, which was asked.
Okay. Perfect. Zach, can I just ask that you forward that mail to Scott, please? All right. So if there's anyone else, yeah, please just let us know, and I'll forward that list. As I said, I hope it's quite comprehensive. So there's 4 models that I've provided or prepared, and I'll start with the mid-surfacing one first. And I just want to draw your attention to the function that I've activated on this monitor, and I hope you can all see it clearly. And that's first of all the halo around the mouse, to just make it clear to everybody where I'm pointing at. And then when there's a left click and a right click or a middle mouse click, the colors are different. So maybe you can just pick up on that. But the most important part is the keyboard keys that I would press are automatically shown on the screen. So if I use any key at any stage, like for instance, if I delete something, it will actually show what key I've pressed. So mid-surfacing. Okay. So I just want to draw the attention to a number of the different features that we have in the mid-surfacing tool, to those of you who are new to the tool. So the first and the third option. The third option is actually being replaced by the initial option, because they've changed a little bit of the behavior of the first option so that we can directly select the first surface, and it will create the mid-surface of that. You have the option to select either of these locations. You can also change the location of those markers, which would then dictate where the resulting mid-surface will be, or you can type in a value over here. And the ability to type in a value is essentially the same as the third option. So that third option is essentially obsolete at this stage. Now, clearly, in a model like this, the shape and the feature was not really well suited for that. So this is where the manual method is essentially not suitable in cases like these. Or if I select that face, obviously that doesn't make sense either. The next option is the automatic option that I would use predominantly most of the time on geometries, but you can also see that in many cases it fails or doesn't really produce the result that you were after. And the reason for that is that the auto mid-surface option, the second one, is actually more suitable for constant thickness solids. So if we have a strange shape like these, the fourth option is actually the better one to choose. So here we can actually choose a face. It will, in the second step, show us the pair element or the pair face, and then if we surface or commit to that option, it then actually generates a more appropriate mid-surface than previously. So in cases like these, you would manually click all the one side faces. In the next step, it will show you the pairs or the pair elements. And then in the last step, it creates your mid-surface. So this is a very useful tool specifically for various varying thickness solids or more complex elements like these where there's T-sections where the interfaces should actually be, or the mid-surfaces should actually be extended to intersect. If we don't do this and we use the manual method, it may or may not work. And as you can see, it then also only uses the first section to dictate or determine where the mid-surface would be. So for varying thickness structures, this is the better tool to use. All right, so I thought I'll just draw your attention to those. Next up, if I remember correctly, is the DFeaturing that fails on a complex solid. Okay, I'm just going to mute incoming video on my side so that it reduces a little bit of the bandwidth load. Okay, so if there's no further questions, I'm going to draw your attention to this piece of geometry that I've received this week. And I found that the default DFeaturing tool failed on one specific section. And I thought maybe that would be a nice example to show how to deal with pieces of geometry when you know the tools don't work properly. And it's not always clear to know why a certain feature would fail. So you know that in the DFeaturing tool, we also have different options. So the first one is basically a case-by-case option where you just pick one surface at a time, and it defeatures it. The middle one is the one that I wanted to use in this case, purely to defeature these fillets so that it's in a more appropriate shape for hex meshing purposes, so that I don't have as many elements. So if I switch to fillets, first of all, it shows you two ranges of sized fillets. So we see there's a big fillet at the back and smaller ones in the inside. But obviously I don't want to remove those ones over there. So all that I'll do is to actually reduce the range interactively over here, and you'll see immediately those fillets then fall into the green category and not in the blue category anymore. And if I watch closely, I see that, okay, only the fillets that I want to remove is selected. Now, if this range becomes very small and difficult to see, you can also change the number over here to just a smaller value so that the different ranges are clearer. And if you want to differentiate between the other sizes, well, let's just go back to the original. You can at any stage just click anywhere here and manually change those values as well to change or essentially create different groupings of the differently sized features. Right, so now I think everything is selected except I don't want to get rid of those fillets over there. So let me just remove them out of the list. I only want to get rid of all the blue ones. So I'll select the blue range and middle mouse click to select it. And lo and behold, everything except one area cleaned up. And this is the area that I want to focus on in this session. As you can see over here, there's a range of fillets. Although they were included in the selection, it did not defeature. Next logical step is to try and defeature them manually. And even press Alt and double click to select them or switch the automatic one off. Now that obviously is not going to help. So let me select these manually. And again, I see I can't get rid of this feature. Okay, so now I want to show you a tip. Well, there's actually two ways to attempt to get rid of features like this, and I'll show you both methods. The first method is to use the PushPull tool. And maybe I should first just explain how the featuring works and when it doesn't work. And I think I'll try my best at this tool. So let's say we have a curve over there, a curve over here, and a straight face over there, and another curve over there. Oops. Okay, so that's my best attempt. Or we have a feature like this that curves and immediately curves and goes straight. Now, if I defeature and I select this edge to be defeatured, it can only result in a solution if the remaining faces can extend to a logical solution. So where that face ends, the remaining faces should be able to be extended. In a case like this, where we have these two fillets adjacent to one another, there is no solution if I select the first one to be removed, because the second fillet will actually try and do that. So there's no logical solution to defeature these. And we'll have to pull a few other tricks. So there's something similar happening in this case, although it's not quite clear. So one option that I'll try is to use my push-pull up to tool and select this face and pull it up to that one. Now, strangely enough, this one fails as well. So it means there's definitely something going on with this piece of geometry that does cause this issue. I can try and select multiple ones and see if I can push them up to this one. And for some reason, it also fails. So there's definitely something wrong. I can try my cleanup geometry. That normally helps. See if it works now. And in this case, it worked. Okay. But what I actually wanted to show you is if that did not work, because I've also had cases like that where even doing the clean up feature did not solve the real issue. And then you have to pull a few other tricks out of the hat. And the one trick that is not that obvious is the ability to delete faces on solids and deal with them as a hollow solid. For instance, purely going into any tool that gives me the ability to select a face and then pressing delete turns this solid into a hollow sheet. So when I select any face of the solid and press delete, it brings up this warning and says deleting this face will turn the solid into a sheet body. Do you wish to continue? And in this case, this is exactly what I want. But what you'll notice on the top here, at this stage, let me just cancel this. At this stage, this is a solid. So if I show the solid, I see the solid. Okay, there we go. It turns this body into a hollow shell. We can now see that, sorry, I'm on the wrong. Now there's only a surface and not a solid anymore. So there we had a solid in the tree, and after deleting that face, it becomes a surface. Right, so I'll delete these two faces as well as a way to get rid of that feature because the DFeaturing feature failed. And now I'll have access to all my sheet and surface feature tools, like for instance the ability to drag this edge to match up to the extension of that face over there. And now I just have to do this for these three edges, and then just take care of what is happening on the sides here before filling it in and recreating a solid again. So now I'll just switch to straight edges and I'll pull this edge that's curved over there into this location over there. I'll go back to the top and I see I have a similar problem there that I just need to correct. And now I can selectively take these edges and snap them to the other ones. And as you can see, I'm starting to close the gap. Now over here, I need to pull a different trick, because if I'm going to do this, I'm essentially going to move this feature edge, which in this case, I don't want to move. I actually want to retain it in this area. I actually want that location to go down there. Well, actually not. I actually see that there's a bit of an angle that I need to get rid of as well. So I actually need to move that. And now I can decide to close that. But I have a problem, and you have to be careful for this. So what happened there was I was in straight edge mode, and then I lose the rounding of that edge. So you have to switch back curvature, and then I can do that without a problem. Although I can see there's a slight issue over here, which will probably be better fixed if I, sorry, let's just get back into this position, and it will probably be better to do it like this. All right, but now I still have this gap that I want to close, and the easiest trick over here would be to actually add a vertex on this edge, which now essentially creates a new edge that I can drag to this one over here. Although in this case, this node is actually splitting this face. So I'll just simply right click on it and delete it. And if I can't delete it, I'll just move it. So if deleting an edge or a feature or a vertex doesn't work, try to move it, and it typically does. And now I can drag that edge to this edge, and I've refilled my solid. and my sheet was automatically turned back into a solid. So that's how you deal with undefeaturable features that for some strange reason just doesn't want to work. Okay, any questions on what I've done over here? All right,
no.
so okay, if no questions on that one, I'll move on to the next one, which was also a interesting case. So this is now one of those scenarios where the featuring fails because there's no logical solution for the remaining faces. So when your remaining faces are parallel, like in this case, there's no way for them to extend and get rid of this feature over here. So the featuring fails. So a simple trick in this case is to merely get a flat face in this region that I can either snap these two or get rid of whatever is remaining. So a very simple solution is to switch to the splitting tool, and I'll switch to the option to actually generate split surfaces that are, well, actually different solids. So I'll select my tool, and how this tool works is you first select any feature that will orientate the split the way you want it. So in this case, I want the face to be parallel or perpendicular to the center over here. And the easiest would be to just purely pick another face that is orientated the way I want to, and then click on the ball and relocate it to where I want it. So in this case, I want to put it somewhere here. That's more or less what I wanted. And now I have a piece of rounding that I can simply delete. And now I have a face, a flat face, which means I have a defeaturable feature because the remaining faces is selectable for defeaturing. So let me just switch to this mode. So now I've essentially fixed that rounding. And the reason I've done that was to reduce the amount of elements when I mesh. Because if you see, if I'm going to mesh this guy with a rather coarse mesh just for illustration purposes, you see that I generate 15,000 elements. But if I remove or undo to that phase and I mesh it now, I generate 26,000 elements purely because of the detail that it needs to retain here. And if that's not the level of detail that you're interested in, you save a lot of simulation time by removing the unnecessary refined meshes. All right, so that's what I wanted to show in terms of defeaturing features like that and ways to get around that. Right, so if there's no questions on that, I'm going to move to the last one, which was the hex meshing example. And this is purely to show for those of you who are fairly new to Apex or who haven't used hex meshing before. The first step is to identify which items are hex meshable and which aren't. Now you can either enter the hex meshing tool and they will automatically be recolored red and green as to which ones are hex meshable and which aren't, or you can switch it on over here so that you have access to this in any other tool. And the reason you will want to have this active in a different tool is the ability to now manipulate the geometry so that we can indeed actually hex mesh this body. Now, as you can see, the reason it isn't hex meshable is because of all these features following in different directions which doesn't resolve in a simple way to hex mesh it, or at least at this stage Apex can't identify how this thing is hex meshable, although they've progressed quite far. So with every release you'll actually see it has the ability to hex mesh more and more features. Like for instance, there was a stage when it was not possible to have split faces on one side of the extrusion and hex mesh it. So if you had a feature like this on the one face, initially it wasn't able to take that into account, and this body would have been green. As the releases, as new releases are added, they actually eliminate a lot of these limitations for us. So, but this one is still the exception. So for this one, we'll now not create different bodies, but we'll actually just partition the solids. And because this is a flat face, I can use it as a plane to split it off in that way. Or what I could do is to select this curved face as a guide. And now you can see that the bottom part is hex meshable, but this top part is still not hex meshable. But that can easily be rectified by choosing one of the other options and simply selecting 3 locations, maybe like this, which should result in an hex meshable body over there. And now because all my bodies are green, I can continue to hex mesh all of them. And as you can see, obviously very coarse mesh, but you can see that Apex has self-identified a paver face and the perpendicular extrusion face based on that. If you want to change that, it's also possible, and you do that by using this option over here. Sorry, let me just switch that off. Sorry, no, that's not what I wanted. That's the option that I needed, user defined sweep face. So what will happen now is it gives me the ability to pick the face that I want to use as the extrude face. So in this case, I'll just choose that face instead. And now you can see the mesh result is different because it's essentially paved the top face and not the side face. And as you can see, even for my last model over here, even though it's a very coarse, bad mesh, it was able to hex mesh that. And that's it for today. That's the examples that I wanted to show. I would like to see more questions. If you have any, you can feel free to unmute your mic and ask them, as well as give us an indication of the topics that you would like to see in the next session. The other question, or the other thing before you leave, I would ask that you complete our survey at the end of this session. In the reminder email that I sent out this morning, there was a link to the survey where you can just indicate how useful the session was for you personally, as well as any other questions that you may have or would like us to have addressed.
Paul,
yes,
we have two questions for the mid-surfacing part.
Okay, sure.
Both of them deal with assigning thicknesses after you've mid-surfaced.
Okay, brilliant. Good. Was that the questions? Just to have
the one question asked which mid-surfacing tool can you use that will assign thicknesses automatically, And the other question was, if you have an irregular body, how do you assign the thicknesses for that? So with an irregular thickness profile.
Understand. Okay, perfect. That's a good question. So with irregular bodies like these, the only mid-surfacing tool that assigns the thicknesses automatically is this one. So what we saw in this case was that these bodies didn't mid-surface very well with this functionality. Although it assigned a thickness, that was not the mid-surfaces that we were interested in. Okay, so that body is not suitable. But using the other tool, we can still generate the mid-surfaces and assign the thicknesses automatically, although we just need to provide, or it's just one additional step. And the way you do that is to activate this attribution panel. And here we have the auto thickness tool that was initially put in before the thicknesses were automatically assigned. And how this one works is you just need to have these bodies meshed beforehand. So I'll just hide the solids for now. I'll surface mesh these bodies. I just want to stitch some of them. There's my stitching tool. I see those two have red edges, so that means they're not stitched. Not that it's really important. This one as well. So I'll just do that for formality's sake. And so that's the requirement, is that you need a mesh, because the mesh actually dictates in many cases the outcome as well. So you have to have a mesh, and then of course you have to have your bodies. So it's now just a matter of selecting the mid surfaces, middle mouse click, selecting the bodies, and the thicknesses are automatically assigned. The important thing here is that the mid surfaces didn't need to exist, or they didn't need to be created in Apex using the mid surfacing tools. You can actually use any surface in any location, as long as it's obviously inside a solid. And then you use this tool to purely use the solid to map the thicknesses onto the surfaces. So internally, there doesn't need to be any relationship between the mid surface and the solid. It does a spatial mapping of solid onto surface. So over here, it shows us the values. And as you can see, I've used large elements. So obviously, each element will have its own thickness now. And I can also render it. If I just hide my solids, I can render it in various ways, either through the fringe method or the physical solid method. So this now shows me exactly what is happening mathematically with my thickness and elements. So if I just switch the wireframe for the solids on, you can actually see how each and every element represents a different thickness. And just to show that those mid surfaces didn't need to be come from the actual solids, you can actually move a surface into a different position, and Apex will still attribute the offset property correctly. So I'm just going to do this now for this guy. And as you can see, even the offset, even though I've actually exited the solid in this case, I didn't mean to do that, but it worked well. So even though the physical shell element is outside the solid, the property was still assigned properly, providing the thickness of the solid in that area, as well as the offset property. So it will mathematically work exactly in that way. So using the visualization tool is also a nice way of just checking how it was done. Maurits, was there anything else left?
No, not as far as I can see. All the questions are answered.
Okay, fantastic. All right, so that was it for today. And if you can think of anything else, I'll appreciate it if you can just enter the survey, also complete the survey. I have it on this one slide as well if you want to type it in manually. Otherwise, you can find it in the link that was sent in the reminder email of this morning. And yeah, if there's no further questions, thank you very much for joining us. Yes, was something asking it?
Andre.
Something?
Andre.
Yes, Andre.
Yes, Paul. I would like to maybe the next time, if you can just recap the things you explained to me yesterday about this reaction forces. I managed to set that planes, but to get it the post processor, I couldn't get that sorted out. But maybe the next time you can actually discuss that planes.
Okay.
You know that one we discussed yesterday,
Yes.
reaction forces.
The cross-sectional force sensors.
And especially post-processing, how to get it activated, because I set it up in a model, but then the post-processor, I couldn't get hold of it, get the handle on it.
Okay.
But that's fine.
That's a question about the X section force sensor over here. I'll make a note that we say something about that in the next session then.
Thank you, Paul.
Thank you very much. If there's no further questions, then go well and enjoy the weekend.